All right, next. Let me share my whole screen. I'm going to use my calculator a little bit this time. Okay, so I want to show you how to do some logs. Let me get rid of this. It's out of my way. Okay. All right, so to do logs, let me make my picture a little bigger here so I can talk to you. All right. So as I said yesterday, when we were doing, let me get rid of some of this. We'll talk about this when we're done. When we were doing this yesterday, so 2 to what power gives you 2? And we say that we know that x is 1. And that's something that we just know. We know that because we know some algebra. And then it went, it gets to a certain point where that's about our limit. So here x equals 2 and x equals 3. But what about this one? 1.25 to what power gives you 3.85? Now, if you're doing a rate law and you know that they're whole numbers, you could just guess. Well, it's obviously not 1, because 1.25 to the first power is not 1.25, or is not 3.815. But you could square it and see if it's that squares. You could cube it and see if it's cubed. But here's where, and I don't know that you'll come across this in AP chemistry, but this is a skill definitely that you should have. Not so much because you may not recognize these, because as I said in AP chemistry, you can just guess. Try square, try cube, see if it works. But in chemistry, beyond that, x does not have to be a whole number. So that's where this can get tricky. It doesn't have to be a whole number. So if it's not a whole number, now it's impossible to guess. All right, so how do you do the algebra to get that right, in case you don't know? All right, so let me bring actually all of this back up. Actually, it doesn't look like I even have it here. All right, I guess I don't have it here. You know what, I just moved that one slide and now I don't have it here, but let me just show you. So let me show you what it said. I'm trying to think of the numbers they use in algebra. I guess it doesn't matter. So I'll just say m to the x equals 5, whatever it is, 5.25, something crazy. We don't know what it is. All right, so how are you going to solve for x in this case? So there's a rule in algebra that you need to know. It's the logarithmic rule, which is if you take the log of both sides of this, so take the log of both sides. This side is really the key. Do you know how to do that? So the log of m to the x power, the log of m to the x is equal to x times the log of m. So the exponent goes in front, and then you take the log of that number. So it's the log of m to the x is equal to x times the log of m. Now over here, it doesn't matter because it's a number. We could put that number right in our calculator. All right, so let me show you how I do this. So let me start with this one, actually. Let me take the log of both sides. So we have 1.25 to what power gives us 3.815, or something as easy as 2 to what power gives you 8. Let's do this one first. So take the log of both sides. So over here we get x times the log of 2 equals the log of 8. So rather than knowing log rules, because there are rules when you multiply them, you divide them, you subtract them, you add them, there's rules. I try to simplify your life so that the logs we need to know, we can deal with in AP chemistry all the same way. All right, so here's how you do it. So now it's easy because now I can plug in my calculator. I can put in the log of 8. So the log of 8 is 0.903 is equal to the log of 2 is 0.301. Divide both sides by 0.301, and you can see, 1. And so x equals 3. So, we knew that x equals 3. 2 to the third power is 8. We know that. So there's the algebra. So there's solving the logs. All right, what about this one then? So over here, it's x. Again, taking the log of both sides. So the log of 3.815, 0.581. The log of 1.25, 0.0969. And x equals 0.581 divided by 0.969. And it comes out to be 5.99, which is probably 6, so 5.995. So there's where it is a whole number. And you could have checked, tried 1.25 to the second, to the third, to the fourth, and see if you get it right. But in beyond AP chemistry, it could be not a whole number. So you take the log of both sides. Now, there are some others we need to know how to do. The one I just showed you gets the majority of them done for you, but there are some other logs that we need to mess with. And for us, you know, log and ln, natural log. So ln, for us, the execution of the algebra is the same. You just use a different button in your calculator. All right, let's go back up to the top here, though. What about number 1? So now I have the log of, can I drag this? Yeah. So the log of x. All right, so now I can't take the log of both sides, obviously, because I already have a log. So whenever we have the word log, we have to take what is referred to as the anti-log, the antilog. Now on our calculator, that's the 10 to the x button. Because this is a log-based 10, you do 10 to what exponent to get rid of it. So whenever I see the word log, I'm going to do 10 to the and 10 to the on both sides. Now what the 10 to the log of x does is it cancels out log. So this is x equals, and then you can either use the, so you can see my button is right there above log, 10 to the x. I also have over here a caret button, so I can actually use that as well. So you can see I need x is equal to 10 to the 0.5911, and so I can do 10 to the 0.5911. So x is 3.90. Or I can use my anti-log. So there's what it looks like for me. You can see it looks a little different, 0.5911. You can see it gives you the same thing. All right, so that's the first one. So when you see the word log, you use the anti-log button. When you see the word, well, it's not really a word, I guess. When you see the, oops. When you see ln, so now we need to know the opposite of ln. So the opposite of ln is not 10 to the, because that's the base 10. It's e to the. So e on your calculator is usually associated with ln. And with me, again, it's here's my ln button, and then right there above it is that e dx. So e to the ln gets rid of the ln. And now we have e, I have to hit second to get to mine, 2.079. And we get 7.996, probably 8. Again, if we're looking for whole numbers, 8. And then we already did the third one. So third one, we took the log of both sides. What about the opposite? All right, so instead of the log of both sides, once again, now we're going to take, so now we have ln. So how are we going to get rid of e? Well, if we were to do 10, let me do number 6 first, because I think number 6 might make a little more sense. So number 6. All right, so if to get rid of logs, we use the 10 to the x button, then to get rid of 10 to the x, you use log, yes. So if we take the log of both sides on this one, now think about what we're doing there, log of both sides. So it's the same rule we had before, 10 to the x. So we get x times the log of 10 equals the log of 2.399 times 10 to the 5th. So you see the parallels there? Again, that's why I like to do math the way that I do math. Now, if you're not sure what the log of 10 is, you put it in, the log of 10. So you can see the log of 10 is 1. So there's 1, and x equals. So then you just take the log of 2.399 times 10 to the 5th. And we get 5.38. All right, so what about number 5 then? So, you know, getting a little bit more challenging again. All right, what are we doing this time? Well, we could do that same rule. We could take the log of both sides. Take the log of both sides. So what do we have now? 3.75 times the log of x equals, I'm just going to get that number. So the log of 31.07, which is 1.49. So now you can see I can get the log of x equals 0.397. All right, how am I getting rid of that one? Well, I already showed you that. It has log in it. So now we're combining a couple of steps. We're combining the fact that we have to do the log of both sides. And now I'm back to the same as what we had in number 1. I got to get rid of log. How do I get rid of log? I do 10 to the anti-log. That's essentially what that's called. So there it gives me x, and then 10 to the 0.397. And we get 2.49. So there's one where the exponent is, it wasn't an exponent this time, but it wasn't a whole number either, so we can solve it. So then the last one would be number 4. Again, using that same skill. Now we have both skills involved. I need to get rid of the e. So the way we got rid of the 10 to the x is I take the log of both sides. So now I take the ln, natural log of both sides. So you want to look at it as, you know, canceling the e, or look at it as x times the ln of e equals, so now we're not using the log button, but the ln button, 0.01426, and you get negative 4.25. X equals, well, the ln of e, I don't know if that'll work actually. Maybe e to the first, so maybe ln of e to the first. And that works, yeah. So the ln, just like the log got rid of the 10 to the ln gets rid of the e. And that was it. Yeah, so that's the last one. So try this, hit pause for a second, and then I will show you the answer. All right, so let's do the bottom one first. So solve for x. All right, so we're solving for x. We can't just try to do this randomly. It'll be a nightmare. So what you do is take the log of both sides. So we get 2.35 times the log of x equals the log of 3.725. And we get 0.571. The log of x equals, divide both sides by 2.35. 0.243. Got to get rid of log, 10 to the. So x equals 10 to the 0.243. And so we get 1.75. All right, so that was the log question. All right, so how are we doing this one? All right, jump right in. I'm going to do those two. Why? Because that one's not changing. And this one is doubling. So 2 to what power equals? It's going from 9.6 times 10 to the minus 6 to 1.92. That looks to me like it doubles as well. If you are unsure, 1.92 times 10 to the negative 5 divided by 9.6 times 10 to the negative 6. And you can see it as 2. So 2 to what power gives you a 2? A rate equals k times a to the first. All right, what about b? Well, in b, you can see we want to use those two. B is also doubling. I'm looking at it now going in that direction, not the other way. I could say it's halved, but I like to make it so that it's a number greater than 1 instead. Makes the squares easier. So going in that direction, you can see we end up with also doubled, and so b is also to the first power. What is the rate constant? Plug them in. We're going to plug in a rate. I'll just pick the first run. So there's the rate equals, so divided by 0.04 to the first and divided by 0.04 to the first. So the rate constant K is equal to 72,000 units 1 over molarity seconds. You could also have molarity seconds minus 1. You could also have moles meters minus 1 second minus 1. So now that we know what K is, we just plug in those initial concentrations for A and for B. So 72,000, A is 0.12 to the first, B is 0.015 to the first, times 0.12 times, and we get 130. Units would be molarity per second rate. All right, so just some more practice. So move on to the next video now. So the next video you're going to see we're talking more with rate laws and a few other more specific